After we just identify where the angle, then we need to look at certain points. First, we need to have an idea about the iris contour, the most peripheral part of the iris. It can be slightly convex, can be very convex, it can be flat, or can be concave. Slightly convex iris is the normal. You get the most peripheral part of the iris slightly convex. Flat iris, you can see it in two cases. In cases of big-sized eye, myopia, or aphakia, when the lens is not there, and also the flat iris, flat peripheral iris, you can see in cases of plateau iris. Plateau iris is a condition where the ciliary processes are thickened, enlarged, and pushing the peripheral part of the iris forward, and you get an occluded angle. The difference between the myopia or the aphakia and the plateau iris, here you get the iris drawn back and the angle is widely opened. But in cases of plateau iris, you get the ciliary body pushing the iris forward. So the iris is seen at the level of the trabecular meshwork or Schwalb's line. In cases of myopia or aphakia, you can see the trabecular meshwork nicely. But in cases of plateau iris, the iris is pushed forward and you don't see the angle is closed. A concave iris, you can see it in cases of pigment dispersion syndrome and pigmentary glaucoma. In this UBM, you can see that the peripheral part of the iris is concave. On the slit lamp, you can see that the central part of the iris is more pushed compared to the peripheral part of the iris. We can watch this video, and you notice that the central area of the iris is pushed more forward compared to the peripheral part. This is the concave appearance of the iris in cases of pigment dispersion syndrome. And if the tension is high, we call it pigmentary glaucoma. So the first point is to have a comment on the iris contour. The second is to see the width of the angle, the distance between the most peripheral part of the iris and the Schwalb's line. How many degrees could be this angle? Then you see the structure visible in the angle. In this drawing, here you can see all the structures, and this is the Schwalb's line here, and this is the trabecular area and the ciliary recess on the iris. Here the iris is a little bit forward that we don't see the ciliary recess. Here part of the trabecular meshwork is not seen. Here the iris is at the level of the Schwalb's line, and even here the Schwalb's line is not seen. So you get what is visible. Everything is visible down to the ciliary recess, or nothing is visible on the extreme end. Then you get a wide angle or a closed angle and grades in between. Here you can see this is the iris, this is the ciliary recess, this is the trabecular meshwork. Here nothing is seen. The angle is totally closed. Then you may meet any of these abnormal things. You may find peripheral anterior synechiae. This is the normal fine iris strands, while this is the widened, the broad areas of peripheral anterior synechiae. So this is to differentiate between synechiae, which are widened areas of occlusion of the angle, and the normal fine pigmented lines, the normal iris processes. Again, here we get the normal iris processes, and we get here a more widened areas of peripheral anterior synechia. The second is new vessels. Sometimes we see vessels in the angle, and we have to differentiate between a normal vessel that can be seen in the angle and abnormal vessels. To know the normal vessel, let's see the anatomy again. We have a group of anterior ciliaries, they are 7. We get 2 vessels coming from one of the 4 recti, except the lateral rectus will give us 1. These vessels run on the sclera before reaching the limbus, 3 millimeters, pierce the sclera inside the eye. And we have 2 long posterior ciliaries coming from behind. They penetrate the sclera, move between the sclera and the choroid, sclera and ciliary body, to the ciliary body itself. So here, you all are familiar with this section. You get here the cornea, sclera, ciliary body, and as you see here, the iris is embedded in the middle of the anterior surface of the ciliary body. This is the anterior ciliary vessel. It is on the surface, running toward the limbus. Before reaching the limbus by 3 millimeters, it penetrates into the eye. And this is the long posterior ciliary, running between sclera and ciliary body. They meet and make anastomosis to form the major arterial circle, which is located in the ciliary body at the root of the iris. From the major arterial circle, vessels run radially inside the iris toward the pupil. If this is the surface anatomy, this is the location of the major arterial circle. And these are the radial vessels running in the stroma of the iris. This is the drawing of the angle. You have here the iris, and this is the ciliary recess, and this is the scleral spare, and this is the trabecular meshwork. This is the location of the major arterial circle. It is embedded in the ciliary body. It is not visible. It runs circumferential like this. From this major arterial circle, we have these radial vessels running in the stroma of the iris toward the pupil. Now, we come to abnormal vessels we may see. Sometimes this part of the major arterial circle is not embedded, and it is on the surface like this. So if you see a large vessel oriented circumferentially in an area, this is part of the major arterial circle, and this is a normal. Again, these radial vessels, sometimes one of these radial vessels or more is apparent. It's a large vessel. It runs directly radial. It does not branch. It's one of the normal vessels of the iris, but it's not covered with the stroma. And the third possibility, this anterior ciliary vessel. Imagine that it didn't come here. It's a little bit forward here to reach to the canal, to the major arterial circle. So this part will be visible. One major vessel coming through the sclera toward the ciliary body, not branching, run radially. So these are the 3 possibilities of seeing a normal vessel in the angle. Part of the major arterial circle, or one of the radial vessels of the iris, or the anterior ciliary is forwardly displaced. I want to show you this video. Here we get a blood vessel. This is reddish. There's only one vessel seen here, almost at 12 o'clock position. This is the anterior ciliary vessel visible. So normal vessels are broad. They appear for a short segment. They do not extend anterior to the sclera spare. They do not arborize on the trabecular meshwork. This is the abnormal vessels. They arborize, they run diagonal, they can extend anterior to the scleral spare. If they are on the surface of the iris, they are diagonal, like here. Here, this is an angle which is opened, but still you can see very multiple fine lines, reddish in the angle. These are abnormal vascularization. The cornea is edematous, that's why the image is not that clear. But you can notice all these fine lines are arborizing blood vessels. These are abnormal vessels in the angle. The last thing is the amount of pigmentation in the angle. Normally there is some pigments on the normal trabecular meshwork. But abnormal pigmentations can be found in exfoliation syndrome, heavy pigmentation. It used to be segmented in areas of the circumference. Or in pigmentary glaucoma, it's a diffuse pigmentation all over.